Hello, this is Zelin's class, and today we are going to finish up the yesterday's question, and we are also going to do some new stuff. So let's get started. Well, yesterday's question we have finished the part A. So if you are not if you forget some of the part A, you can go back and check. So now let's read the question again, which is there is a line that intersects a curve at 3 points, and now we have got the x coordinate, which is x equal to 1, negative 3, and 5. So now let's look at the part B, which is find the gradient of the curve at each of the points of intersection. So our curve is 2x squared y minus x squared minus 26y minus 35 equals 0. And we need to find the gradient of the curve at these 3 points. So what we need to do? Well, firstly we need to write something in terms of x. So we need to change the subject of y, and we learned this in IGCSE, which we will do y times 2x squared minus 26 and move x squared and 35 to the other side, which equals to x squared plus 35. And we can divide the 2x squared minus 26 on both sides, which becomes y equals 2x squared minus 26, and here's x squared plus 35. So now we get the subject of y in terms of x. So now because we need to find the gradient. So how do we do the gradient? Gradient is same as our differentiation. So now let's differentiate y. So let's try to find y dash. So how do we find y dash? This is something divided by something. So we should try to use our quotient rule. And this we discussed yesterday. And if you are not familiar with this, you can check my yesterday's video. And now it's y dash equals to 2x squared minus 26 squared, and here we get 2x times 2x squared minus 26 and minus x squared plus 35 bracket times 4x, and this is our quotient rule, the result of the quotient rule. And we don't need to simplify it, because we need to find the gradient when x is equal to 1, negative 3, and 5. So we can just simply by substituting x equals 1, negative 3, and 5. So now let's assume y equals fx. So f dash 1 equals 2 times negative 24 minus 36 times 4 over 2 minus 26 bracket squared. And let's simplify this, which is negative 48 minus 144 over negative 24 bracket squared. And let's solve this, which negative 48 minus 144 over, which is negative 1 over 3, and our answer is negative third. So this is a part of our answer, and we need to do the same thing for other case, which is when x is equal to negative 3. And let's do this. And this is equal to 9. And so we do the same thing for 1f dash 5 because x is equal to 1, negative 3, and 5, and we need to find this point, which is equal to negative 5 over 3. I skipped that because you can, because it's just simple like calculating. So now we have done our question. So our 3 gradient, when x is equal to 1, the gradient is negative a third. When x is equal to negative 3, the gradient is 9. And when x is equal to 5, the gradient is negative 5 over 3. And we solved it. See this question, it's very long, this question. And yeah, it's quite difficult. This is just only the part B. So yeah, maybe you should try to read it for 2 times and maybe you can understand it quite easily. And now let's move up to further differentiation theorems. This is the derivative of exponential function, which is fx equals e to the power of x. Then f dash x is same as e to the power of x. The proving is on page 88 in our textbook because the proving is quite complicated and it's not in our curriculum. So I'm not going to prove it, and if you are interested in, you can go and read by yourself. However, I am going to prove the more important one, which is the derivative of e to the power of fx. To prove this, we need to use our chain rule. So what is chain rule? We talked a bit in AS last year, but I'm still going to teach you. So what is chain rule? Chain rule is something we can, so for example, there are 3 variables, x, y, and u. And now, because our aim is we want to find dy over dx, which is the normal differentiate. However, we can't solve this straightly. So how do we do this? Well, sometimes we know that dy over du, we know the value, like a, so we know. And also, we know du over dx equals b. We also know. So from here, by timing these two together, we will get dy over du times du over dx, which is dy over dx equals a times b. And this is the chain rule. So we have 2 differentiation, but with 2 other variables we know. And when we times together, we can know the 3rd variable, differentiation. So now, let's do this, which is ef to the power of fx. And, well, simply we can't solve it straightly. So we are going to use our chain rule. So how do we use it? Let's assume fx equals u. And efx becomes e to the power of u, and this is equal to y. And now let's try to differentiate y dash. So we know that y dash is equal to dy over du, which is equal to same as e to the power of u. And now, because we know that because u equals to fx, so our u dash, which is equal to du over dx, is equal to f dash x. That makes sense, right? Yeah, that is. So now we have 2 values. And according to the chain rule, when we time these 2 together, we can cancel out 1 variable. So see, du and du, we can cancel both of these. And this is dy over dx, and it is equal to e to the power of u times f dash x. And we know u is equal to fx. So, which means dy over dx is equal to e to the power of fx times f dash x. And that is our final solution. So, we have done this. And yeah, that is all for today. And we are going to do some more questions tomorrow. And yeah, make sure to subscribe me and give a like if you really like this video. And also, if you are interested in GCSE math, I suggest you to go to this channel by Daniel Dallas. And thank you all.